Hi everyone! Today we are going to be answering the essential question of how do we identify terms and like terms in algebraic expressions. So you've already learned about algebraic expressions and looking at clue words, but we learned about those when they were only using integers. So now that we've learned about rational numbers, we're going to start to combine integers and rational numbers into our learning around algebraic expressions. So if you remember, an expression is just a math sentence. It doesn't have an equal sign. Okay, so expressions are just a math sentence that has coefficients, it has variables, and it has constants. And so our job when we have algebraic expressions is to be able to combine the things that are the same and simplify down eventually to the things that are not alike so that we can solve when given the number for the variable. All right, or the value for the variable. So first of all, let's talk about the word like terms. What are like terms? Well, like terms are just what they sound like. They are parts of the algebraic expression, so like the pieces that make up the expression or the sentence, and they have things that are the same, whether it's the same variables or the same exponents, or they are just plain constants. So like terms are the parts or the terms, the parts of an algebraic expression parts of the algebraic expression that are the same. And we'll do some examples right now to talk a little bit more in depth around what does that mean. But for now, like terms are the parts that are the same. Okay, so the parts that are the same are the terms that are the same. All right, so example A, it says to identify the terms. So first we have to identify the terms or the parts. Maybe we could put terms in parentheses here. First we have to identify them, and then it wants us to put the things together that are the same or identify the like terms. Okay, so example A. Example A, our algebraic expression is written like this. We have 9x minus 2 plus 7 minus x. Okay, so this is our expression. This is the algebraic expression. In order to be able to find the terms or the parts that are the same, our job first is to rewrite this so that everything looks like addition. Remember when we were learning about integers, I took away subtraction? That is following us now into algebraic expressions. So you're going to take this, and the first step here is going to be to rewrite. So we're going to rewrite it as a sum of terms. As a sum of terms. Okay, so that is step 1. So let's go ahead and look at our terms that we have right here. That means that these things right here that are negatives are now going to be adding a negative. Okay, so instead of subtracting a number, we're just going to add a negative. So our new sentence is going to look like this. I have 9x plus a negative 2 plus a 7 plus I also have a negative x. So all I've done is I've taken my -2 and I've turned it into a -2 within parentheses because I'm adding the opposite. So instead of subtracting a +2, we're now adding a -2. Okay, same thing here. We're adding a -x. So that when we solve this, everything looks like addition. So we're rewriting as a sum of terms. That is right here. Okay, our next step now is to find the terms. So now we're going to list out the terms. So step 2, we're going to list the terms. Okay, so in order to make up this sentence or to make up this expression, I need a 9x. I also need a -2. In order to make this sentence, as if this were like a recipe, I would need a 7. And last but not least, I would need a -x. These are the things I need in order to make this sentence. So what we're going to do now is we're going to identify the things that are alike. So we're going to now, step 3, identify like terms. Not everything has a like term, but in this sentence, we happen to have like terms. So we have a 9x right here. This x and this 9x, they are like terms. So our like terms, so these were just our terms, and our like terms are 9x and x, and then we have some constants here. These constants, this 2 and this 7, these two things are like terms. So our also like terms are -2 and -x. And you don't need to keep putting parentheses around these. You can just write them because we're just listing. Okay, so notice we have the ones with the x's, and then we have our constants. These are, I meant 7. Why did I put -x? I am so sorry. -2 and 7. I hope that didn't confuse you. And our constants. Okay, so we have, wow, I just messed that all up. There we go. We have 9x and -x. My goodness, Miss Englander, what is happening to your brain right now? And we have -2 and 7. Okay, let's do another one so that it doesn't confuse you. And I apologize for making a mistake there. All right, so example B. Okay, in example B, the expression that they give you looks like this. You have z squared. Okay, plus we have 5z. We have minus 3z squared. And we have plus z. Okay, our first step is to rewrite as sum of terms. So anything that's a minus, we're going to now rewrite this so that it's adding. So instead of z squared, I'm now going to have just a z squared still because there's no negative sign. I'm adding 5z. This is the one that matters because there's no addition sign. So we're going to put a plus -3z squared. And then we're going to add a z. Okay. Now we need to list out the terms. So the terms in this, the terms that are in this list, the things that we're working with in order to make this math sentence are z squared plus 5z. We don't need this plus sign. There we go. -3z squared. And we also have a z. Okay, now we're going to put together the things that are the same. Identify our like terms. So our like terms, the things that are the same, z squared is not the same as z. They both have a z, but they are not the same. So this one has an exponent. This one does not have an exponent of 2. So z squared and this negative 3z squared, these are going to be the same. So our like terms are z squared and negative 3z squared. Those are like terms. Okay, those ones are the same. Same type of terms. Okay, we also have in this list, this has a z and this has a plain z. So 5z and z, these are also like terms. 5z and z. Like terms. Okay, let's do one more example. And then from there, it will be your turn to do a try it. All right. So I'm going to do another one that happens to have a lot of negatives in it, just so that you can get used to combining that. So we have 3y minus 2 minus 4y plus 6. Okay, so our job now is to rewrite this so that it does not have minus signs, right? So we want these to become negatives. So our new expression is 3y plus negative 2 plus negative 4y plus 6. The reason why we're rewriting it with addition signs is because you can use the commutative property, which we will do tomorrow, to simplify these things. So in addition, you can commute your numbers. When it's subtracting, you're not able to. So by adding in this addition sign, we're going to be moving this negative 2 over here to this positive 6 so that we can work with those two constants and putting the variables with the variables. We're not able to do that until they're in addition. Okay, so if you're sitting there and you're like, why does she keep doing this? That's the why behind it. Okay, now what we're going to do is we're going to put together or list our terms. So here are the terms. The terms that we are working with are 3y, negative 2, negative 4y, and a 6. Those are the terms that we are working with. Okay, things that are like terms. Let's check out our like terms. So, like terms, we have two sets of like terms here. Like terms. We have our y's. So we have a 3y and we have a negative 4y. Okay, though that is one set. Our second set of like terms that we have are the constants. We have negative 2 and we have 6. 2 and 6 are alike because they don't have any variables. 3y and negative 4y are alike because they both have y's. All right, it is your turn now to do a try it or two. So we're going to go ahead and change the page. So hit pause if you need to keep writing. Otherwise, let's go to the next page. And again, I'm sorry I made so many mistakes in that first problem. Whew, hopefully you're doing better now. Okay, slow and steady. Just got to go slow and steady there. All right. Oh, they always do this to you, and that's okay. But in this try it, they're going to give you a rational number. It's fine because you're not doing anything with the rational numbers yet. Tomorrow, we will. All right, or in our next lesson, we'll do rational numbers. Okay, so right now, this expression is y plus 10 minus 3 over 2y. Okay, So that is try it number 1, which is a great try it because you're going to have a lot that will show up that look like that one. And try it number 2, let's go ahead and do this one with the exponents. We have 2r squared plus 7r minus r squared, and we're going to subtract 9. Okay, so go ahead and solve these. Remember to rewrite it first, and then only choose the things that are the same, the terms that are the same. All right, so rewriting this problem, I have y plus 10, and I'm going to add negative 3 over 2y. Okay, so I need to add this in there. Now we're going to list out the terms. So our terms. We have a y, we have a 10, and we have a negative 3 over 2y. Those are the terms. And last but not least, our like terms in this problem, we're not using everything again. The only things that are the same are the y and the negative 3 over 2y. We don't need to worry about this 10. It can just stay up there in the terms column. But our like terms are y and negative 3 over 2y. So these are alike. Don't worry about the 10. Okay, and now let's go ahead and check out our next problem. We're going to rewrite this. So we have 2r squared plus 7r plus a negative r squared plus negative 9. Okay, now we're looking at the terms. So our list of terms that we have, the terms that we're working with today, the ingredients to make up this math recipe are 2r squared, a 7r, a negative r squared, and a negative 9. Okay, so let's start now by identifying things that are the same. So I see this is an r squared, that is an r squared. So both of these are the same type of term. 7r does not have a match, and this constant does not have a match. So the only like terms that we have, are 2r squared and negative r squared. We're going to go ahead and ignore the other two for now because they are not like terms. All right. Go ahead and answer your essential question. Check how did you do on both of these. Were you able to identify the terms and then the like terms? And then answer your essential question, how do we identify the terms and the like terms in an algebraic expression? So go ahead and answer that question. And then put your level of understanding out to the side. Where are you at right now with this understanding? It's okay if you're still level 1 because we're just reintroducing this right now. So go ahead and put your level of understanding there. And then when you are finished, you can head on over to the Google Meet and ask for help if you need it. Or you may go into Big Ideas and do your practice work. As always, I appreciate all of your hard work and effort, and make it a great